Alright, hi guys, I'm going to go over 5.1, which is angles and their measure. Most of it should be a review of Math 3, but it's just going to give you hopefully a basis of the trigonometry unit. You can see three angles right here. The initial side, which is right here, and the terminal side. The initial side will always lie on the positive x-axis, and you have the terminal side, which is the other part of your angle. So if it goes counterclockwise, it'll be a positive angle. So that is example 1 and example 3. And then you have this guy that goes backwards. So you notice that it has a clockwise rotation. So that guy's going to be a negative angle. Now, what's different about number 3, if you notice, is that he actually goes past the initial side. So he makes a full rotation. Hopefully you remember that a full circle is 360 degrees, so this guy's actually going to be more than 360 degrees, and we're going to talk about that in a second. So we have 4 different quadrants here, so we're going to actually make a little diagram over here. Now our 4 quadrants are 1, 2, 3, and 4. Now I'm going to go ahead and label my degrees just on my 4 quadrants. So I always start over here on the right side at 0 degrees. I know a full lap around is 360. That means halfway around is 180. At the top would be 90, and at the bottom is 270. So basically you should first of all know if I told you an angle like 45 degrees. What quadrant does that lie in? That lies in quadrant number 1. You should also know 0, 90, 180, and 270 are what you call quadrantal angles, and they lie on your 4 quadrants. I'm also going to talk about something that isn't specifically in your packet, but you talked about a lot in Math 3, something called coterminal angles. So coterminal angles are angles that lie in the same location on your circle. Okay, so we're just going to focus on degrees right now because we haven't talked about radians yet. But for example, let's start with 40 degrees. So 40 degrees, you should know, lies in quadrant 1. It's not quite halfway to 90, but it's close. So 40 degrees, oh, and I just turned that blue. We're going to go with it. 40 degrees lies about right there. Now, if I want to get back to the same spot on my circle, I have 2 options. I can either go all the way back around. Now, how would I get there? To go all the way back around, I have to add a full circle. A full circle is 360 degrees. So that's going to give me 400 degrees. So therefore, 40 and 400 are called coterminal angles. Now, my other option, if I start at 40, is I could go backwards. But I still have to go a full circle, because otherwise I'm not going to get back to the same spot. So I would have to minus 360. And that leaves me with negative 320 degrees. Now, know that 40 and 400 and 40 and negative 320 are not the only possibilities for coterminal angles. I could keep adding 360, I could keep subtracting 360, but I can't add, for example, 100, because if I added 100, that would not get me back to the same spot in my circle. So my only options in degrees are to add 360 or to subtract 360. Now, these pictures that you see down here are just examples of what I talked about above. So if I go halfway, that's 180. If I go a quarter of the way, that's 90. If I go a full revolution, that's 360. We'll talk about coterminal angles with radians in a few minutes. So what I recommend you doing is pausing the video for a second and try to draw each of these angles yourself. So I would draw each of your 4 quadrants and see if you can just sketch where the angle would be. Alright, so hopefully you have this sketched and you can check your answers. So 45 degrees should be exactly halfway. Obviously, you can't get it exact because you're just estimating, but exactly halfway between 0 and 90. Now, negative 90, remember when I have negative, I have to go backwards. So it's actually going to end up exactly where 270 is. Okay. Now, if you didn't remember that it went backwards, since it's a negative, I can find the coterminal angle, and I could add 360, and I would get 270. So that's another way to think about it. 225 is going to be down here in quadrant number 3. And 405, now, wait a second, that's bigger than 360. So I'm going to find the coterminal, which is subtracting 360 because it's too big, and that gives me 45. Some people like to show that it went around more than once. With an arrow like that, I wouldn't be too picky as long as you get it in the correct location, because 405 and 45 are coterminal angles. Alright, so next we're going to talk about something called degrees, minutes, seconds. This is probably a little bit new. You don't talk about it in Math 3. Really, your calculator does all the work for you, though. So go ahead and have your calculator handy. Now, degrees can actually be broken down further into what are called degrees, obviously, minutes, and seconds. So each degree can be divided into 60 minutes, and that's what this little symbol is called. That's a minute. And then each minute can be divided into 60 seconds. So basically, it's just, can we divide it down further? And like I said, your calculator will do all the math for you. It's just a lot of button pushing. Okay, so I'm going to show you, have your calculator handy, and I'm actually going to do it as I do it with you because it can get a little bit lost. Okay, so the first thing you're going to do is you're going to type 50 in your calculator, because we're going to try and convert this guy right here to degrees. This right here says 50 degrees, 6 minutes, 21 seconds. So first thing you're going to do is you're going to type 50. Then you're going to go to second apps. Now, second apps, if you notice the little writing above says angle. So, number 1, you should notice, has a degree symbol. So right now, you should just have this typed in. So hit number 1 that has the degree symbol, so then on your calculator, it should look like 50 degrees. Don't hit enter yet. So then, we're at number 1. Okay, then you're going to type in 6. And then go to second apps again. Scroll down to number 2. And you'll notice that's the minute symbol. So now you should have the first 2 blocks on your calculator screen. Then you're going to type in 21. And then here's where it gets tricky because they couldn't make it easy. That is not under the second apps menu. So you have to hit alpha plus, and that's where you get the quotation marks. And I messed up for a second, so here we go. All right, so hit alpha plus, and then you can hit enter. And you should get this that we would normally round to 3 decimal places, so that would be 50.106. degrees. So we took that from degrees, minutes, seconds, and we turned it into degrees. All right, we can also go backwards. This one's a lot less work. So we're going to type in 21.256, second apps, and go down to number 4 that says DMS, that stands for degrees, minutes, seconds, and hit enter, and that is our final answer that I just crossed out. That is our final answer. 21 degrees, 15 minutes, and 21.6 seconds. And we'll write it just like that. All right, so next we're going to talk about radians. So radians are another way for us to measure angles. And really, once we get into the meat of it, once you get to calculus and when we get into the depth of pre-calc, we're going to be using radians for everything. Degrees are no longer. So for a circle of radius 1, so this is my radius right here, okay? The rays of a central angle with a measure 1 radian would intersect an arc of length blank. For a circle with radius 3, the rays of a central angle with measure 1 radian would intersect an arc of length blank. So before we answer this question, I want to go down to the formula below, or I guess on the next page. And that's the arc length formula. So it says, for a circle of radius r, the central angle of theta, radians, subtends, that's a weird word, but basically it means what is the angle in the middle. So what is that angle right there? An arc whose length s is s equals r times theta, okay? So one important thing to point out here is theta must be in radians, okay? Theta must be in radians. So to get your arc length, you're going to take your radius times your angle measure in radians. Okay, so now let's go back to these. Okay, so I want to know the arc length right here. So I know that right here it says a circle has a radius of 1. Okay, and the circle with the central angle measure 1 radian. So 1 radian. So 1, 1, that's my eraser. Okay, so 1 times 1 equals my arc length. So remember, this was my radius, and this was my theta. We said theta was 1 radian. We said my radius was 1, and that should give me my arc length. Well, 1 times 1 is 1, so that is my arc length. We can do the same thing with the big circle. For a circle with radius 3, okay, that's shown right there. So 3 is my radius, and it says angle measure of 1 radian, okay, so that's theta, equals my arc length. So 3 times 1 is 3. Okay, so it's not too bad when it's in radians. You have the option when it's in degrees of, I'll show you how to do it in a few other steps, or you can always just convert the degrees to radians, which we'll talk about in a little bit as well. So find the length of an arc of a circle with radius 2 meters, subtended by a central angle of 0.25. So we have our formula, S equals R times theta. So my radius is 2, so I'm going to plug that in, and my central angle is 0.25. So all I got to do is a little bit of algebra here. 2 times 0.25 equals 1/2. Now I always want to go ahead and label what I'm talking about. Arc length is just the circumference of part of your circle. So I'm talking about meters here, and it's just a length. It's not going to be squared because circumference is just the length around the outside. So it's just 1/2 meters or 0.5 meters. So the last thing the last couple things on here is converting from degrees to radians and radians to degrees. So you probably recognize these formulas, pi over 180 and 180 over pi. That's how you convert back and forth. So we're going to start in degrees and go to radians, and then we're going to go from radians to degrees. Okay, so you notice you have 60 degrees here. So 60, and if we're going from degrees to radians, we're multiplying by pi over 180. Now, if you get something like these you should be able to simplify without a calculator. So I get 60 pi over 180. So I know my final answer is going to have pi in it. So really, I'm just trying to simplify this 60 over 180. Zeros are going to cross out. 6 over 18 is going to be pi over 3. Okay. All right, next one. 150 times pi over 180. So really you're trying to simplify this 150 over 180. The zeros are going to cancel out. So 15 over 18 is going to simplify to 5 pi over 6. All right. Next one, negative 45 degrees. Now don't freak out about the negative unless it tells you that it needs to be between 0 and 360 or 0 and 2 pi when we get to radians. Your final answer can be negative, and that's okay. So negative 45 times pi over 180. So again, I'm simplifying this guy right here. This one's a little bit trickier, but you probably remember, or hopefully you remember, 45 degrees is one of my kind of key angles here. So that's going to be negative pi over 4. Next one is a 90 pi over 180. And 9 over 18 is 1/2, so pi over 2. And last one, 107 pi over 180. And that doesn't simplify at all, so I just leave that as 107 pi over 180. Okay? Alright, now we're going to go backwards. So convert each angle in radians to degrees. So pi over 6, and I'm actually going to write over this so that I can cross some stuff out. So instead of pi over 180, it's 180 over pi. So my pi's are going to cancel out, and I'm left with 180 divided by 6, which is 30 degrees. Again, you should practice these without your calculator, especially ones like this that are pretty basic angles. 3 pi over 2. Cross out the pi. Now, on something like this, we got to do 3 times 180 and then divide it by 2. So 3 times 180, so 18, remember we learned how to multiply, so 18 times 3. So we can do 20 times 3, which is 60 minus 6, that's 540. So we erase this. 540 divided by 2. 540 divided by 2 would be 250 plus 20 is 270. Alright, negative 3 pi over 4. So times 180 over pi. So we just said that 3 times 180 was 540 divided by 4, and we know that's negative. We got to carry that negative with us. So if we divide that by 4, we know what's 500 divided by 4. We can do, that would be 125. 125 plus 10 is negative 135. Okay, so it just takes a little bit of algebra there. Alright, 7 pi over 3 times 180 over pi. Alright, so 180 times 7 would be, I think that's 12 something. Seven times 8, 1260 divided by 3. So that would be 420 degrees. So for those of you guys that might be wondering how I'm doing that in my head without a calculator, so I did 1200 divided by 3, which is 400, and then 60 divided by 3, which is 20, and added them together. Alright, so this one you notice it doesn't have a pi in it, okay? So 3 times 180 divided by pi, okay? So I just get right here 540 divided by pi degrees. Now, if you didn't have a calculator, you just have to leave it exactly like that. There's no simplifying that can happen. Alright, so last one is area of a sector. Now, the formula they give you is if the degree is in radians. However, I usually find it easiest to use the degree or use the angle in degrees, okay? Because you guys are really familiar with the area of a circle, and then you can just find that. So area of a sector is just the area of part of a circle, okay? So I always say in Math 3, you find the area of the circle and multiply it by the part you want. So the area formula for a circle is pi r squared. Okay, hopefully we know that, and you can see that in our formula here. And then we multiply it by the part that we want. So I take my theta, I'm going to call it x since they use theta for radians right here, divided by 360 degrees, because I only want, let's say that's 45 degrees. I only want 45 over 360. I only want a fraction of the circle. And that's usually a little bit easier to remember that formula. I want the area of the whole circle and then multiply it by the part I want. So let's do this last example here. Find the area of the circle of radius 5 feet formed by an angle of 40 degrees. Okay, so we're going to do this without our calculator, and then we'll type it in our calculator just to see what it is. So pi 5 squared. That would be the area of the whole circle. But then I don't want the whole circle. I'm going to multiply that by 40 over 360. So 25 pi times 40 over 360. So we can cross some stuff out, and we get 25 times 4 is 100. And that would be 1000 pi over 360. So 100 pi over 36. And let's see, what can I divide both sides by? I can divide both sides by 4. So 25 pi over 9. So 25 pi over 9 would be your final answer. And what are we talking about here? We're talking about feet. But if it's area, remember that would be feet squared. All right, so you can also type that in your calculator. Now, remember, if you have a calculator, the easiest thing to do is just type that part in black in your calculator. So 40 over 360, 8.727 feet squared. So that would be that. Hopefully you didn't get a little too thrown off by the mental math in this section. It's a lot of, I just want you to get used to being able to do stuff when you get to calculus without your calculator. If there is a final exam, you will be able to use your calculator on all the pre-calc final exam, but when you get to calculus, a lot of this will be without a calculator. So I just want you to get used to being able to find these angles, converting from radians to degrees without a calculator. So hopefully we're just getting through the process of thinking through that kind of stuff and being able to do that stuff without a calculator. Okay, so we'll go on. Next video is going to be on the unit circle and reviewing that. Okay, so that's it for 5.1. See you guys later.